Deep sea diving, real-life applications of gas laws. Deep sea diving is a form of scuba diving in which the diver can exceed the recreational diving limit of 40 meters. While deep sea diving requires some extra specialized equipment, both scuba divers and deep sea divers use many protective and assistive devices that allow them to dive far below the water's surface. These devices are necessary to ensure a safe dive, as the environment deep underwater can be extremely harsh on the human body. These phenomena can be attributed to various chemical principles, which will be covered later in the presentation. The term scuba actually stands for self-contained underwater breathing apparatus. This essentially means that the diver is using equipment that allows them to breathe underwater without any supply from the surface air. The different pieces of equipment used in a standard dive are the snorkel and mask, a wetsuit or dry suit, scuba gloves, fins, scuba tanks, regulators, dive computers, and a buoyancy control device. The snorkel and mask are used by beginner divers, usually when swimming horizontally on the surface. The mask allows the diver to see underwater. The wetsuit and dry suit help to regulate your body temperature if you are diving in an extremely cold or extremely warm climate. The scuba gloves can keep your hands warm underwater and can prevent injuries when diving in rocky areas. The fins allow the diver to propel themselves through the water quickly without using too much of their energy. And, arguably the most important devices in diving, the regulator, scuba tank, and dive computer provide the diver with a supply of breathable air, help to connect this tank to the diver's mouth when they're inhaling, and help the diver keep track of the depth, pressure, and length of their dive. The last device, the buoyancy control device, provides a way for the diver to keep a neutral buoyancy under the water, or a positive buoyancy as they move towards the surface. It is used when the diver is changing depths. Today, there are many applications of both regular scuba diving and deep sea diving. Scuba divers are mostly recreational divers who want to explore natural phenomena like saltwater reefs and underwater caves, or to observe marine and plant life in their natural habitats. Deep sea divers, on the other hand, are usually professionals who dive to gather data or to observe a particular underwater site. They often dive to collect data on biological marine ecosystems, to monitor the status of pollution, oxygen concentration, and other key bioindicators. Deep sea divers are also sent out to shipwrecks and plane crash sites to survey the wreckage. They can help provide a clearer picture of what might have happened. They can help identify the bodies and can help recover any valuable pieces of information or items from the crash. Chemistry has many applications in underwater diving. The most applicable lessons from chemistry are the lessons on gas laws. Scuba diving is all about getting gas into the diver's body while they are underwater. This allows them to breathe. This seems like a fairly simple concept. After all, we have ways to transport air in tanks, and we have regulators which allow the diver to breathe. However, what complicates this process is the way that gas behaves at greater pressures deep underwater inside the human body. It is now part of scuba certification programs to know and understand the gas laws that apply to deep sea diving. The first gas law important to note in deep sea diving is Boyle's law, which relates the volume and pressure of a gas while held at a constant temperature. This law says that when you increase pressure, the volume of the gas decreases, and when you increase volume, the pressure of the gas decreases. The relationship between pressure and volume is inverse. This is important during the ascent and descent of a diver. As you descend underwater, the pressure increases and the volume of air in your lungs decreases. This means that the same amount of air takes up less space in your lungs. The buoyancy control device will appear to deflate, the wetsuit will fit less snugly, and the airspace behind your ears will become decompressed. A process called equalizing allows you to let more air into your eustachian tubes to compensate for the reduction in volume. When you ascend, the opposite happens. the buoyancy control device will appear to inflate, and your ears will begin to experience the familiar popping sensation. It is most important to note that in this stage, divers must exhale air from the lungs when ascending to stay safe. As the pressure decreases, the volume of air in their lungs increases, and this increase in volume of air can cause damage if they retain too much air in their lungs. Another gas law important in diving is Charles' law, which relates temperature and volume. This law says that temperature and volume are directly proportional. As you descend into cooler water, the volume of the gas in your lungs will decrease. Similarly, as you ascend, the temperature increases and so does the volume of air in your lungs. Dalton's law of partial pressure is the third very important gas law affecting deep-sea diving. This law states that the pressure of a mixture of gases is equal to the sum of each component's individual pressures. As pressure increases, partial pressure also increases. The air compressed in a scuba tank is a mixture of 79% nitrogen and 21% oxygen. According to Dalton's law, as the diver descends, they are breathing increasingly more dense air, which means that they are correspondingly inhaling more oxygen and more nitrogen per breath. It is very important that divers know this, as inhaling increased amounts of these gases can be detrimental over long periods of time. The partial pressures of each gas are responsible for the physiological effects of scuba diving, such as oxygen toxicity and nitrogen narcosis. Knowing the applications of gas laws in deep-sea diving is extremely significant because deep-sea diving can be very dangerous if anything goes wrong. For example, if the diver does not know that they need to exhale as they ascend, the increasing volume of the gas in their lungs can cause the lungs to rupture. This is called a pulmonary barotrauma. This is an extremely severe injury, and this would mean that they would require emergency medical treatment. The diver could even die from these severe injuries. The partial pressures of oxygen and nitrogen at deeper depths can also cause problems such as decompression illness if the diver stays down for too long. The increase of nitrogen can cause nitrogen narcosis, and the increase in oxygen can cause oxygen toxicity, which can lead to convulsions and unconsciousness. Should a diver go past the safe maximum operating depth for their breathing tank, they become susceptible to these ailments. Decompression sickness is more serious and can occur when the ascent of a diver is too quick. The inert nitrogen gas that is dissolved in the body and bloodstream can come out of solution too quickly to form bubbles in the blood. These bubbles can injure bodily tissues and can block blood vessels, which can lead to the dysfunction of the spinal cord, brain, and lungs. This can also lead to paralysis and even death. Decompression sickness is more commonly referred to as the bends. Knowledge of these gas laws and the behavior of such gases at high pressures allows deep-sea diving and scuba diving to be done safely by those who are brave enough to try it.